Okay, enough about types of networks. Let's finally dive deeper and figure out what this network even consisted of and how does it actually work. How is data being transferred between the networks, and how does each network know which device to forward which data to? Well, these are the questions that we want an answer to, and answer lies in the way that network is structured. There are several devices you may or may not have heard about, and these include routers, switches, and modems. These are crucial, for example, for your home network, for you to be able to access internet from your computer. Of course, it's the cables that are important, but what's the use of cables if we don't know who to forward the packets to? So, how does it all work? Well, let's start by talking about routers. Now, a router acts as the traffic director of a network. They are responsible for directing data packets between different networks, such as local area networks and wide area networks. This leads us to router's number one purpose, which is routing. Routers use routing tables and algorithms to determine the best path for data to travel from its source to its destination. They make decisions based on IP addresses, ensuring data reaches its intended target efficiently. It is also important to remember that routers work at layer 3 of the OSI model, which deals with IP addresses. Now, the OSI model is something that we will talk about later in the course, but for now, just remember that router functions on layer 3. Now, typically, routers today will perform the functionality of both a router and a switch. That means that the router will have multiple Ethernet ports that devices can plug into. Another use of routers is for network segmentation. Routers help segment networks, creating distinct broadcast domains. This segmentation enhances network security and reduces congestion. And also it is important to note that routers often perform NAT, or Network Address Translation, allowing multiple devices within a LAN to share a single public IP address. This conserves IPv4 address space and adds a layer of security. Now, I do understand that some of the terms that we talked about might be confusing for you, such as, for example, IPv4 or public and private IP or NAT, but don't worry about it for now. This is something that we will talk about shortly. For now, just focus on the main usage of these network devices. So let's repeat. Router is responsible for directing data packets between different networks by using routing tables to determine the best path for data to travel from its source to its destination. But what about switches? We mentioned that in some cases, routers can perform both functionality of a router and a switch. But what is the functionality of a switch? Well, switches, they use the MAC address of a device to send data only to the port the destination device is plugged into. Switches work at layer 2 of the OSI model, which deals with MAC addresses. Switches maintain MAC address tables to understand which devices are connected to which ports. This enables them to make forwarding decisions efficiently. That cable going out of your PC into the switch port is written inside the MAC address table inside the switch, so it knows exactly where your computer is and on which port should it forward the data to for it to arrive to your PC. Now, some of the pros or usages of switches are switches form the majority of network devices in modern data networks and carry huge amounts of traffic in telecommunications provider networks. Switches provide the wired connections to desktop computers, wireless access points, printers, industrial machinery, and some Internet of Things devices. They offer full duplex communication, connect network segments, boost network performance, and make effective use of available bandwidth. Now, network switches can be easily confused with routers. However, they have different functions and operate on separate layers. These differences include things like, for example, a network switch is a layer 2 device on the OSM model, and a router is primarily a layer 3 device. A router moves data between 2 or more computer networks, while a switch facilitates the sharing of resources by connecting multiple devices on a single LAN. To determine the route and destination of a packet, a router examines the IP addresses of packets, and a switch looks at the MAC address of each device to transfer data to the correct destination. Routers can work within both wired and Wi-Fi networks, but a switch is in most cases restricted to wired network connections. Okay, so these are some of the main differences, but we have to mention one more device, which is modem. What is a modem? Essentially, a modem is the device that physically connects your network to your ISP's infrastructure. It establishes the initial internet connection by translating digital data from your network into a format that can be transmitted over the ISP's network. Modems are essential because they're designed to work with different types of physical connections and communication standards or protocols. Each type of modem is tailored to a specific type of infrastructure or medium, allowing it to transmit and receive data over that medium effectively. Here are some examples. DSL modems are designed for transmitting data over standard copper telephone lines, typically using the digital subscriber line technology. Cable modems are meant for transferring data over coaxial cable lines, commonly used for cable television services. And for example, fiber optic modems work with fiber optic lines, which transmit data using light signals. Now, same as with switches, modems can also sometimes be confused with routers. So to summarize the differences that you should remember, we can say that modems and routers are complementary devices in a network. Modems provide the link between your network and your ISP, enabling internet access, while routers manage local network traffic and provide additional features like Wi-Fi connectivity and security. In many home network setups, these functions are combined into a single device for convenience, known as a modem-router combo.